What this talk is going to be about really is about the metaphysics of general relativity, in particular in relation to the question of substantivalism. So, just to introduce the view, right now if you find literature in substantivalism, you'll find that it's not a single view, it's rather a family of interrelated views about spacetime. And there are two main theses comprising this family of interrelated views. The first one I call existence. Spacetime exists. The second one I call independence. Spacetime has features that do not wholly depend on the distribution of matter and fields within. And again, there are many ways to interpret these two theses. For example, Ehrman and Norton interpret independence as a thesis that the properties of spacetime can vary modally without there being a difference in the spatiotemporal relations between matter and fields. Right? So you have an axis of independence there. Dasgupta interprets independence as a grounding thesis, as the thesis that facts about spacetime are not grounded or do not depend on facts about the spatiotemporal relations on matter and fields. For the purposes of this talk, I will be ambiguous about what exactly the interpretation of these two theses are, but I will just say that it consists in these two theses interpreted some way. So there are two main questions concerning substantivalism in the literature. The first one is substantivalism true? And the second one is, does GR entail substantivalism? So is it true in the worlds where GR is true? Or does GR support substantivalism? So Dasgupta, for example, asks whether conditional on GR being true, our credence in substantivalism increases or decreases. So these are the two main questions, and there are many ways of approaching these questions, but they are roughly divided into two families. What I will call the metaphysical approaches and what I will call the formal approaches. So the metaphysical approaches ask questions about modality or grounding when it comes to the worlds where GR is true, and answer these questions using tools that are commonly used in metaphysics, like possible world semantics, first-order logics, grounding frameworks, and so on. An example would be Teitel, who asks whether there are pairs of worlds in which general relativity is true, and such that they differ only by uniform redistribution of all fields, and everything else stays the same. Dasgupta, for example, asks whether facts about spacetime or facts about the spacetime manifold are grounded in facts about the locations of matter and fields, or whether they are independent from the facts about the locations of matter and fields. So those are two recent metaphysical approaches. There are also, we can also talk about Jeremy Butterfield, who asks whether these worlds differing on the locations of matter and fields and nothing else means that determinism is false, or things like that. I also consider him as advancing some kind of metaphysical approach to the question of substantivalism. And there's this second family, which I call the formal approaches. And formal approaches focus on structural features of GR's formalism, so in the mathematics of GR, and use tools like model theory or category theory to argue for or to block metaphysical conclusions about the subject matter of GR. So an example could be Rosenstock, Barrett, and Wetherell, which argue that substantivalism is actually equivalent to relationalism because the categories of models of substantivalism and relationalism are dual to each other. Another example is Wetherell arguing that the whole argument, which is an argument, a popular objection against substantivalism, is based on a misleading use of the mathematics of GR and therefore is not a valid objection. So this family of approaches actually what they do is they take the mathematics of GR and they use the mathematics of GR to either block or advance conclusions about the metaphysics of GR, or the subject matter of GR. And at first glance, these approaches should be complementary, so there is nothing actually conflicting between these two approaches, but in practice, proponents of metaphysical approaches and proponents of formal approaches are in tension. So what I will try to do is try to bridge some kind of gap between these two approaches. And I will try to bridge this gap by advancing some perhaps obvious idea. The obvious idea is that the methodology to answer the main questions of substantivalism and GR is to regard GR as an interpretive theory. So this means that we should accept two things. First, that GR already determines conventions to describe the possibilities it specifies. Right? So questions like whether GR allows for possibilities that differ only haxaetistically or that do not differ on qualitative properties, or whether GR worlds are purely qualitative, or whether facts about space-time are grounded on facts about relative locations of matter and fields. All of those questions should be tackled first using the interpretive resources that GR gives us. And if they cannot be tackled by that, then maybe try something else. So this is the first thing. The second thing, the second consequence of accepting that GR is an interpretive theory is that formal or category theoretic results do not settle metaphysical questions on their own. So if I use the fact that two categories are dual to each other, I can advance that as a mathematical result and it will be right, but irrelevant. If I use this fact to argue for or against metaphysical claims about the structure of space-time or the structure of the possibilities where GR is true, I will inevitably need interpretive or metaphysical assumptions to advance my argument. And these two considerations actually are held against first metaphysical approaches. The first one is held against metaphysical approaches. The second one is held against formal approaches. So I will next briefly explain what I mean when I say that GR is an interpretive theory. To do so, I will briefly introduce the formalism of GR, and I'm sure that a lot of you are more familiar than I am with the formalism of GR, so I'll be quick. And this is just to fix some terminology and to set the stage for the proposal. So first, I will talk about what GR is not. In philosophy, what is often used to theories that specify a language and then state some axioms. So for example, set theory specifies a language with the membership relation, and then we state axioms with a membership relation. GR doesn't really work like that. Or a lot of theories in physics really do not really work like that. They can be formulated in many different languages and so on. The way, at least the way I understand GR is that it starts by roughly specifying the phenomena it's meant to describe. So for example, the motion of celestial bodies, the propagation of light, the dynamics of black holes, and so on. Then it specifies a class of mathematical models that will be used to describe these phenomena. And I will call these mathematical models representational vehicles. I'm borrowing this term from Teitel. And third, we specify the conventions for using these vehicles to describe the phenomenon. So more or less, well, actually, David Wallace has a paper stating that lots of physical theories work like this. I think he's right. Now, of course, you may specify a language, but you may specify many different languages and obtain the same physical theory. The so-called essential steps are these three. Now, about the vehicles. The vehicles are what I would call GR modals. GR modals are triples. These are just mathematical objects, by the way. They are triples, MGT, where M is a four-dimensional manifold, G is a Lorentzian metric on M, T is a stress energy tensor field on M, and MGT satisfies the Einstein field equations. I will define mod GR as the class of all GR models. These are the mathematical vehicles that GR uses to represent the phenomena. Now, there are, of course, conventional elements to how we define these mathematical objects. For example, I could have switched T and G. I could have said like, oh, well, I mean, a GR model is a triple MTG, and then go on. And I would have essentially obtained the same representational system. I could have done something a little bit more radical. I could have changed the signature, and then, of course, changed how this system is related to the phenomena it's meant to describe. And I would, again, have obtained the same theory. So there is a lot of conventionality here. But let's do it like this. Right. And then there are conventions that connect these models to the phenomena that these models are meant to describe. And that, of course, I cannot really go on at length about these conventions. I will just briefly say some things. So when I use one of these models to represent or describe a given physical system, each model represents a possible history of that system. The manifold, together with the metric, determines the geometry of the system, and this geometry can be spelled out in terms of space-time points and the relation between them, if you're a substantivalist, or between possible spatiotemporal relations between elements of the system, if you're a relationalist. T encodes the distribution of matter and fields within the system, and it can be used to model continuous media like electromagnetic fields or fluids. It can be used to model point particles, and so on. And additionally, we can add test particles to the model, which are certain points that move along geodesics. And we can use them to represent things that have a small mass and do not really affect their surroundings that much. These are just a few facts about how it's used to represent physical systems. And with this in mind, I will introduce a minimal framework. The framework is minimal in the sense that it makes minimal metaphysical assumptions about the nature of spacetime, and it isn't meant to replace GR, it's just meant to set the stage for the proposal. One important fact is that GR is used to describe both the cosmos as a whole, if you do cosmology, and it's also used to describe isolated systems of the universe. Right? So David Wallace has a paper on that. So for example, we can describe a black hole without paying attention to its surroundings, or we can describe a planetary system using GR. Of course, we need to approximate certain things when we do so, but these are ways in which GR is used. So each model of GR might be interpreted in many different ways depending on the interpretive context in which it is used. And each interpretive context does two things. First, it determines the target system to be represented. So I may say the target system is the whole cosmos, or I may say the target system is a black hole at the center of the galaxy, or the target system is a planetary system, or whatnot. Second, it specifies how I will describe the target system. So it determines the GR-compliant conventions for using this space of models to describe the target system. And I will only say that. Something that's important to say, and I should say now, is that specifying a target system is less than specifying an object in the ontology to refer to. One can, for example, intend to model a black hole at the center of the galaxy without deciding whether it is a plurality of interrelated particles or if it is a patch of space-time or something else entirely. Both in everyday life and in physics, we are relatively successful at the task of specifying a target system without doing so in ways that may satisfy metaphysicians who demand precise specification of our ontological commitments. So specifying a target system is something like specifying an aspect of the world to talk about, without actually articulating the ontological structure of this aspect of the world. So that's what I understand by specifying a target system. And some notation. So I will use M bracket C to express the proposition that the target system of C is in a state modeled by M via cis conventions, if M is a model of GR. If I have a formula phi, I will use phi in brackets C to express the proposition that the target system of C is in a state that is modeled by some M which satisfies the equations or the formula phi. Right? So here, the way I'm using formulas or language is to pick a set of GR models. Right? So I'm not exactly describing the target system with the language. I'm using the language to pick a set of GR models, and then the models model the target system. And of course, here C is a context in which GR models are used to represent physical systems. M is a model of GR, and phi is an equation or formula that models of GR either satisfy or fail to satisfy. And models of GR, well, this is actually important. Here I'm understanding models of GR as mathematical objects. So they are not the systems, they are mathematical objects that will be used to represent the system. Well, before I continue, let's pause for a moment and think about what I am doing. Well, actually, what I am not doing. Here's what I'm not doing. I am not trying to tell you what GR talks about in a way that's independent from the theory itself. Rather, what I'm doing is that I'm taking advantage of the existing conventions of GR and of the fact that GR is an interpreted theory, and using it as an object theory to express the propositions about its subject matter. So here's what I'm not doing. I'm not doing this. This is the ontology, and this is how GR talks about the ontology. So I'm not exactly doing that. What I'm doing is whatever the conventions for talking about target systems are, use these conventions. And I can obtain, so to speak, the space of propositions that I can express using GR. So with this framework in place, let's examine what I have called the metaphysical approaches. So, as I said before, metaphysical approaches focus on modality or grounding-related questions about spacetime, and they use tools like possible world semantics, first-order logics, grounding frameworks, and so on to answer these questions. So one example is Teitel in his paper, How to be a Spacetime Substantivalist. He articulates desiderata for substantivalism. He says substantivalists normally want to accept and should want to accept no shifts. No shifts is the thesis that there are no shifted possibilities. And a shifted possibility is a possibility, well, a pair of shifted possibilities is a pair that differs only by a smooth and uniform redistribution of all fields across spacetime in GR. Now, Teitel argues that obtaining these desiderata is harder than initially thought, and then he discusses some ways of doing so. And all of those ways require dealing with facts about, for example, the trans-world identity of spacetime points. So, no shifts is hard to obtain for the substantivalist because the substantivalist is committed to spacetime points, and there are identity facts about spacetime points that one has to deal with when you want to argue that this possibility and this possibility where everything is shifted 10 meters to the right are actually the same possibility. Right? So consider this spacetime point, the one in my nose. If this possibility and the possibility where everything is shifted 10 meters to the right are the same possibilities, then this spacetime point is actually here, so it doesn't have the property of having my nose on. So apparently that means that there are two different possibilities, right? So most of the discussion is like that. Right? So there is a problem here, or a problem I want to raise, which is that the usual route to no shifts is gauge theory. And Teitel says, well, gauge theory is irrelevant to no shifts. Why is it irrelevant to no shifts? Let's examine Teitel's argument. So, Teitel correctly points out that the route to implement no shifts via gauge theory requires the following: no mathematical shifts. Diffeomorphically related solutions of the Einstein field equations represent the same physical possibilities. So if I have two models and they are related by a diffeomorphism, which is a transformation that shifts the mathematical fields in a way that's uniform and whatnot, then these two mathematical models must represent the same possibilities according to the conventions of GR. So Teitel correctly points out that this is a linguistic thesis, or representational thesis. It's a thesis about how a certain apparatus represents possibilities. And no shifts, which is the thing that we want to obtain, is a modal thesis, not a representational thesis. So the first one doesn't decide the second, right? And he says something interesting. I'll just quote him here. The problem is that no mathematical shift simply does not speak to the truth or falsity of the doctrine we're interested in, namely no shifts itself. No shifts, it's a modal doctrine concerning the space of metaphysical possibilities where the laws of GR are true. By contrast, no mathematical shifts is a doctrine about how we use a particular mathematical formalism. And then he goes on to say, there is nothing incoherent about a substantivalist who accepts no mathematical shifts and yet rejects no shifts. And I think that's technically true. It's not incoherent. But there's something slightly problematic here. And to render it salient, I will just give you an analogy from the philosophy of mathematics. There are people who want to argue that numbers exist, and not only that numbers exist, but that their existence is trivial. So I will call these people neo-Freudians. They argue for claims like the following. In English, the sentence, "the number of dinosaurs is 0, represents the same way for the world to be as the sentence, "there are no dinosaurs." So that this is a linguistic thing. But of course, it's a merely linguistic fact, and it does not appeal to the truth or falsity of a modal claim like the following. For the number of dinosaurs to be 0 just is for there to be no dinosaurs. So that's a modal claim. The first one is a linguistic claim. And here's a fact. A philosopher can accept the linguistic claim without accepting the modal claim, but if the philosopher does that, then they would either commit to a false claim, or they are forced to read this in a language other than English, right? Because if I accept that English is like that, and then I read this sentence in English, it will be true, right? So, to accept both, I would have to actually be using a language other than English. So, this is exactly what's happening in the case of title, in my opinion. So, proponents of no shifts argue for it by advancing claims like the following. Diffeomorphically related solutions of the Einstein field equations represent the same physical possibilities. But this is a merely linguistic or representational fact and does not appeal to the truth or falsity of a modal claim like there is no pair of distinct possibilities differ only by a smooth and uniform redistribution of all fields. And here's a fact. A philosopher can accept no mathematical shifts without accepting no shifts, but in doing so they would either commit to a false claim or they would be reading no shifts using a notion of redistribution of all fields that doesn't correspond to the notion that's used in GR. So I will use the framework to make this even clearer. Define possibilities P and Q to be shift related, and shift related according to the notion of shift used in GR, if P is modeled by M in some context C, Q is modeled by N in some context C, and P and Q are not equivalent. For some context C and diffeomorphically related models of GR, M, and N. So this is what it means for a pair of possibilities to be shift related. If you use the notion of shift used in GR. And here, this equivalence thing is propositional identity. If you are not comfortable with propositional identity, you can replace it by necessary coextensiveness. I think the argument still runs. So, no shifts, using the notion of shift used in GR, is that there are no shift-related possibilities, right? Using shift-related as it is used in GR. No mathematical shifts, using this notion of shift, actually talks about our conventions for using GR. Our conventions for using GR models are such that for any context C in which they apply, and any pair of diffeomorphically related models M and N, what M represents in C is the same as what N represents in C. Okay. The important thing here is that if no mathematical shifts truly applies to our conventions for using GR models, and the notion of shift in no shift is borrowed from GR, then no shifts will be true. That's the important message. So from this we can see that title is either wrong or he's using a notion of shift that isn't borrowed from GR. Maybe he's using a metaphysical notion of shift. That's actually not shift, but just something where you redistribute all the individuals and the qualitative properties stay the same. So he's using the notion that's better called haxitistic difference. Right? There's nothing wrong with using this notion. It is just not the notion of shift that's borrowed from GR if no shifts is true. If no mathematical shifts is true. Okay. So this is the first point of contention, that there is some kind of disconnect between the notions of shift or certain spatiotemporal notions as they're used by proponents of metaphysical approaches and those as they're used by physicists. The second point of contention is that GR already answers the question of what the possibilities where GR is true are like. So I will just quote Teitel and Dasgupta here. Teitel says about non-mathematical shifts. He says, it is also worth stressing how little non-mathematical shifts tells us. We have seen that the doctrine does not imply no shifts. Moreover, the doctrine tells us just about nothing about what possibilities where GR is true are like. Which nomic possibilities do they represent, and what are those possibilities like? Dasgupta, in a different context, says that he proposes some version of substantivalism, and he says, before motivating her view, the thin substantivalist must tell us what the view is. Specifically, she must, one, clearly articulate what the underlying qualitative facts are like, and blah, blah, blah. So, the first pass response to reading this, at least my first reaction is, well, GR is an interpreted theory. It already has conventions to describe these possibilities. So, for a given possibility P, we can answer the question of what this possibility is like using the representational apparatus of GR itself. So, making it even clearer, if I have a possibility partially describing a possibility P in GR in some context C, is giving a non-trivial formula such that P entails the formula as interpreted in C. So, for example, I can describe a possibility containing a black hole, a non-rotating black hole, and nothing else by giving this formula and saying that this possibility entails that this formula is satisfied. Fully describing a possibility P in some context is giving a non-trivial formula phi in L such that P is equivalent to the formula as interpreted in C. Okay, so I will just quickly say something about formal approaches because I'm running out of time. So I have said that considering GR as an interpreted theory has consequences for both metaphysical and formal approaches. So I will now give an overview of how this plays out in the context of formal approaches. As I said, formal approaches focus on the structural and mathematical features of GR, and they use mathematical tools to analyze this structure and arrive at metaphysical conclusions or block metaphysical conclusions. So an example is a paper by Rosenstock, Barrett, and Wetherell called On Ising Algebras and Relativistic Spacetime, and they tackle the question, does it even make sense to talk about substantivalism as opposed to relationalism given current physics? Their answer is no, because they are equivalent. And the argument for their equivalence goes somewhat like this. The manifold formulation of GR is associated with substantivalism. This formulation uses a category of models, which I will call CAT-GR. Relationalism is best formulated using the theory of Ising algebras, and this theory uses a category of models I will call CAT-EA. CAT-GR and CAT-EA are dual categories, so they have the same potential to represent the same possibilities. Therefore, GR and EA are equivalent. This follows from 1 to 5. Therefore, substantivalism is equivalent to relationalism. So there are some problems with this argument. I will raise problems in premise 2 and the intermediate conclusion 6. Premise 2 says that the standard formulation of GR uses a category of models, CAT-GR. And here CAT-GR is a category of models where the objects are the GR models, and the morphisms or arrows or something like that are smooth maps between models that preserve the structure of the metric and the stress energy tensor. So an objection is that it's true that the objects are the GR models. It is less clear that the morphisms are those morphisms. So why is it less clear? First, in physics, one rarely finds discussions of morphisms using a theory, and it's not exactly clear which role they play. Second, that some arguments, like the whole argument, actually seems to presuppose that the morphisms are not those in CAT-GR. And third, that even proponents of formal approaches have briefly considered the possibility that the morphisms are not those in CAT-GR. So it's not a given that the morphisms are those. And also, I don't even know what it means to say that the morphisms of a theory are, well, a given set of morphisms. So it's not even clear what is being claimed when you claim that the morphisms of a theory, have a certain structure. So Halverson actually explores this question, but he explores this question in the context of first-order logic. I don't know what it means outside of first-order logic. So the second thing is the intermediate conclusion, and now I'm going to finish. GR and EA are equivalent. So Rosenstock, Barrett, and Wetherell seem to be arguing for this conclusion on the basis that the categories of models are equivalent in some sense. So they're either isomorphic or dual. But GR and EA are interpreted theories. This means that aside from specifying a system of representational vehicles, like the class of models or the category of models, they also specify conventions for how to use these vehicles to represent these possibilities. What matters here is the conventions for how to use these vehicles, not just the structure of the representational vehicle. So whether GR and EA are equivalent under these conventions is something that will depend on the interpretive assumptions or the way I use these models and not just the structure of the models. So the upshot is that formal approaches need to be supplemented with interpretive premises or metaphysical premises. So arguing for just, these categories are dual, therefore the theories are equivalent is just not enough. So in conclusion, metaphysical approaches often overlook that GR is an interpreted theory and ask questions that are outside of the scope of GR. So for example, asking questions about haxieties and taking these questions to be related to the notion of shift is something that is normally done here. Formal approaches often arrive to conclusions via mathematical means, but the conclusions require hidden metaphysical or interpretive assumptions that need to be independently justified. Since we're not dealing with a bare formalism, but with interpreted theories. And that's all, thank you.
Okay, thanks so much, Diego. I really enjoyed the paper, and I share the main sentiment, which is something like purely formal approaches on their own cannot solve substantive or interesting substantive questions about metaphysical theories, and on the other hand, pure metaphysical approaches that kind of disconnect from how the formalism or the math is used in a theory cannot do that either. So I very much agree with that. And my questions are, I'm just going to mention two big kind of picture questions, comments. Not sure if it's a question, the first one. I was wondering if the tension that you identified between the formal approach and the metaphysical approach in the particular context of GR, can it be thought as a particular instance of, broader or more general tension in the philosophy of physics, and perhaps maybe in the philosophy of symmetries, given that that's the field that I work on, but maybe more general than that too. Like I've seen, for example, a lot of disputes in the context of philosophy of symmetry, not necessarily GR, also electromagnetism, or even go all the way back to the line-star correspondence, right, and Newtonian mechanics, where philosophers with very formal, sometimes they have tackled these questions through the math itself directly. Sometimes they have tried to tackle these questions through more metaphysical approaches. And I was just wondering if you think that this tension you identify is just like an instance of a broader tension in the methodology in philosophy of physics, maybe philosophy of symmetry in particular. So that's the first comment / question, and then the second one, let me just make sure, yes. The second one is about the whole argument more directly. Let's see, maybe I'm wrong, but if I understood correctly, it could happen that there is a physicist who understands very well how to use like the formalism, understands very well, I mean, it's a physicist who has worked in general relativity their whole life, suppose that she knows both the applied side of general relativity and also the more theoretical side, probably knows GR better than philosophers of physics would, right? And then the question is, would this kind of physicists be able to solve, according to your like approach or your framework, would able to solve or like answer like how to solve the whole argument debate, like say, oh, this is how you do it. Or maybe they cannot do that because it relies on things that are like beyond the subject matter of the theory itself. Maybe I mean I'm just trying to figure out like what the implications of your arguments are for this question. Like, what would you need to do to like settle this kind of debate? Would you, besides knowing the physics, or is it only the physics enough? And similarly, and maybe from a slightly different angle, I guess this is related to what it means for the art to be partially interpreted. Is it part of the partial interpretation itself? Like if you have two physicists or two philosophers of physics who know how to use the theory and understand very well, and yet they disagree about whether they're shifted related models or shifted sub-GR related models. Are they disagreeing about actually what the theory is? Like, are they disagreeing about like, the partial interpretation to begin with? And so there is a sense in which they're using different theories, or they're agreeing about what the theory is, and yet disagreeing about something else, and if something else, what is exactly that's going on? So those are my two main questions. Thanks.
Thanks. Diego, if you'd like to respond briefly, and then we'll move to Q&A.
Yeah, thanks, Sebastián. Those are really interesting questions. The first question, I took it to be like, is there a broader, pattern where there's some kind of disconnect between how the math in a scientific theory is used and how people who do metaphysics of science, engage with theory? And I think there is. I don't know the philosophy of symmetries in particular, but I have worked on theoretical equivalence, for example, and a lot of people who do theoretical equivalence, they also divide in two camps, right? One camp that sort of they just analyze the math of the theory and they sort of take for granted the interpretive conventions, right? And they said all of their points just stem from the mathematical structure of the theory, and there's this other camp that sort of try to understand the theory using some, let's say, external metaphysical approach, and then they don't engage with the math of the theory that, that closely. And I think there is some kind of disconnect there. I think perhaps there's a bigger project of trying to bridge these gaps. And I think what bridges these gaps in this case and the case of theoretical equivalence is just broadly semantic or meta-semantic considerations about how we interpret our theories or how we use them or to represent the world and whatnot. So I hope that answer is satisfactory. About this other, this other problem, let's say there's a physicist or there's a bunch of physicists, there are experts at using the system to represent, the representational system to represent the phenomena, and yet they can disagree on whether there are shift-related possibilities or not. I think this always happens. And I think here, there's two ways to go on about this problem. The first one is to say, well, if they disagree about this, knowing full well the theory, that means the theory actually doesn't decide whether there are shift-related possibilities or not. And there's, you need to do some extra things. So you need to do, for example, some metaphysics. So if you have metaphysics where you have individuals and anxieties or whatever, then you will accept that there are shift-related possibilities. If you have a different metaphysics, you will say that there aren't. But this issue is sort of outside of the scope of GR, right? so now it just turned into an issue on metaphysics. Right? So it's not about GR. It's just, you know, you can take that. You can take a right turn in the alley of metaphysics and then stop pretending that this is about GR. So this is the first way to go on about it. The second way to go on about it is that perhaps we can be really, really good at, and this happens with language too, we can be really good at speaking, but the structure of our language is not transparent to us. So perhaps we disagree on, you know, certain things just because the language is opaque. So this happens in natural language a lot. That's why there's a whole field called philosophy of language. The other thing to say is that, well, it happens in natural language. It also happens when we use our theories. The structure, the representational structure of the theories is opaque, and we have to make it clear. So I don't know exactly which answer to take, but yeah, that's more or less the answer.
Okay, thanks. So we have some time for questions now. Let's start with the end, and then if I haven't acknowledged you, please keep your hands up. Yes,
thanks you both. I was wondering if you could say a little bit more about why we should expect something like a uniform redistribution of all fields in the title's substantive axiatistic sense to be represented in a theory like GR. I'm thinking loads of metaphysical questions aren't settled by a theory like GR. Think of questions of personal identity, for example. Suppose a teletransporter. GR doesn't settle if one of the two properties or both or none will exit the teletransporter are identical to me. And I'm thinking maybe questions about how axiatistic, questions about the axiatistic possibilities of spacetime are settled by GR. Contrast this with, for example, a theory which I do think talks explicitly about these sorts of modal questions, which is like a theory like statistical mechanics, for example, where I think it's much more plausible to think that the interpretation of, for example, points in phase space are supposed to be distinct possibilities, like the probability distribution about the probability distribution over modal space. So yeah, I just wanted to get some comments from you on that. Why should we think that GR is a theory that makes these substantive model?
So here's I'm speaking for Teitel now, so I'm not sure if he would agree with what I'm saying, but here's how I'm reading Teitel. If you're a substantialist, you think that there are things which are the space-time points, and in the mathematical manifold, each mathematical point refers to a space-time point. So let's say I'm standing here, and there's a point in the manifold that refers to my nose. There's a point in the manifold that refers to this point, which is part of the ontology. If everything shifts 10 meters to the right, not just me, but like everything, suppose that everything shifts 10 meters to the right, what you did is you kept the same objects in the ontology and you changed their properties, right? So now this point doesn't have the property of having my nose in it. It has the property of having some other thing. Therefore, you produced a different possible world because you have the same objects but different properties. Therefore, shift-related possibilities exist. That's more or less the reasoning of Teitel. Now, there are lots of assumptions. For example, that there are these things in the ontology that something about transworld identity of points, that I can identify this point in the second possibility with this point in the first possibility, and they are the same point. So there are lots of assumptions there, but I think that's more or less the reasoning. I'm not trying to embrace these assumptions. I'm just saying, well, this is how Teitel reasons. I don't know if it helps.
Can you follow up?
We've done it.
Thank you. Quick clarificatory question about the Teitel argument. So if I understood correctly, So you were saying that, so we have the first claim, which was no mathematical shift, which was that P and Q represent the same possibilities, and no shifts is that P is identical with Q, where P and Q are theories or statements.
Let me see, like here.
No, I'm talking about so that slide where you point out that the first can be true and the second false, provided that the meta language and the object language are not the same.
Yes,
so,
this one.
Yes. No, I don't think this one.
Oh, I gave an analogy from the philosophy of mathematics.
Oh yes, I think it was this one.
Yes.
Yeah, the analogic one. Okay. So great. So suppose that the object language and the meta language are the same. So I assume that the first one is equivalent to saying necessarily the number of dinosaurs is 0 if and only if there are no dinosaurs. It's stated completely in the object language, right?
The first one, both of them, you should think of both claims as being made in the meta language. Only the first one talks about the object language, the second one doesn't.
Okay.
Yes.
But the first one should be equivalent to necessarily the number of dinosaurs is 0 if and only if there are no dinosaurs, I assume.
Maybe, so like the sentence, the number of dinosaurs is 0 if and only if there are no dinosaurs is necessarily true or something like that.
Okay.
Yes. Yeah.
Which then should imply necessarily the number of dinosaurs is 0 if and only if there are no dinosaurs?
Only if the meta language shares enough with the object language.
Which is what I was assuming. So I was saying, assuming that they share the relevant vocabulary.
Yes.
Okay, so that still doesn't entail that the number of dinosaurs to be 0 just is for there to be dinosaurs. Because the latter is an identity statement and it's stronger. So,
right.
Imagine necessarily Socrates is Socrates if and only if Socrates is a member of Singleton Socrates. Doesn't entail that for Socrates to be Socrates is for Socrates to be a member of Singleton Socrates.
Okay, I see what you mean, but notice that both of them are identity statements. So I say the sentence blah represents the same way for the world to be as the sentence blah. So that's an identity statement. And here I just said for the number of dinosaurs to be 0 just is blah. So it's like another identity statement. So perhaps that's the problem, that like one of them you're reading like a necessary coextensiveness statement and not an identity statement.
Okay. I'll try to be quick. I was just thinking, if I'm defending a kind of metaphysical approach, someone like the Sutta is taking, is it one way to think about things that if your title isn't the physics of space-time enough? I mean, for some purposes, yes. For other purposes, no. Right? So it might be explaining why there are no shifted possibilities. There's a kind of physics version of that question, and physics is adequate for that. But the metaphysician needs a kind of deeper explanation. What is it about the nature of space-time that explains why GR doesn't permit diffeomorphic related models? In other words, why there aren't these shifted possibilities once they're interpreted in a natural way. So in other words, I mean, isn't one methodology of metaphysics to kind of try to metaphysically explain why the physics is the way it is. So in that sense, what the metaphysician might be trying to do is to explain why we can't represent these possibilities in our physical theory. Because it's this feature of the nature of space-time that prevents us from being able to have shifted possibilities. Something like that. Is that amenable to your way of thinking?
Yeah, I mean, I don't oppose sort of doing metaphysics and trying to say, well, these are the things that we know about physics. Now we'll explain why, why these facts arise from, some more fundamental fact. I think what I oppose is just proceeding like physics don't already answer some questions. Or proceeding or for example, using a vocabulary that's disconnected from the vocabulary used in physics, and then there's some equivocation fallacies there or things like that. I guess I was mainly targeting that kind of problem, right? I'm not opposed to just saying well, these are the words used in physics. I will just use completely different words, and then I formulate my problems in these different vocabulary and make it clear that it's not the same problem as in physics. So that's. I mean, as long as you're doing it right, I don't have any problem with that, I guess. Yeah.
Thanks for your interesting talk. When we were talking about the formal approaches, when we were talking about the sort of formal side, one of your complaints was that they just sort of choose out of the air what the right notion of morphism is for their case. And that's sort of an arbitrary choice, or at the very least, it seems like it's not given sort of a good motivation. I think that you're in a position to say something actually kind of stronger than that, which is that, well, we do have a reason to pick particular kinds of morphisms. The reasons for picking certain morphisms from the category are we want to know what kinds of ways of transforming a model will produce a new model that represents the same possibility. In order to say what those morphisms are, we first need to say how we individuate the possibilities represented by the theory. So we kind of necessarily can't go in the direction that the formal approaches want us to go. And you sort of have to first settle the metaphysical questions in order to have the appropriate standard of individuation of possibilities at hand. Does that seem amenable to your view?
Yeah, I think I would say that. So you actually need to do some metaphysics. You cannot just choose the morphisms and say, well, things are close or whatever. But you actually also need to do some semantics, maybe. So yeah.
Just depending on the interpretational context.
Great. This will be the last question.
Yeah, I kind of needed your slide where you define independence, but that's okay. I can ask the question anyway. It had to do with what other people were saying. What if the question isn't, is space a substance or a relation? What if the question is space or time powerful? And I'm thinking of Alexander Bird uses GR to say continuous time is powerful because of the counterfactual locutions you can make between time and matter. So in that case, would you still say stick to the GR interpretation, or in those kinds of metaphysical questions, could a formal answer surprise us with the right answer?
I'm afraid I don't fully understand the question, but I'm happy to talk about this.
Okay, thanks.
Sorry.
Okay, please join me in thanking